Hi, do you ever wonder why your smartphone's glass is touchscreen? Well, in this video you will find out why. The smartphones we use every day seem so simple but are made of a complex design. But how exactly does the touchscreen feature work? And why is a cracked screen not an issue on the performance of the iPhone?
Most smartphones consist of 5 layers. The bottommost layer is called the LCD layer, or the liquid crystal display layer. Then on top is the actual glass covered by the driving and sending capacitive grid. This is the layer which controls and allows the capability of the touchscreen along with the accuracy. This is covered with a flexible protective cover and the surface coating with anti-reflective properties. Therefore, when a screen is cracked, only the first 2 layers are damaged, allowing for the smartphone to function properly even after the damage.
So, what is the touchscreen made up of? Well, it is made up of indium tin oxide. Indium tin oxide is yellow-green in color, but it is transparent and colorless when deposited as a thin filament. When deposited as a thin filament on glass or clear plastic, it functions as a transparent electrical conductor.
Since indium tin oxide is an expensive material and often rare, researchers at Fraunhofer Institute in Germany have found alternative displays that consist of polyethylene terephthalate, or PET, and a mixture of carbon nanotubes and electrically conducting polymers. The carbon nanotubes create a network where the electrically conducting polymers can be firmly anchored, increasing durability. The electrical conductivity of the system is lower than of ITO, but it is sufficient for application in electrical systems. More importantly, the polymer-based electrode is cheap and can be made from renewable resources.
I recently overheard a woman on the subway telling her friend that her toddler swipes everything in their house. The tables, books, plates, even her own mother, trying to make her disappear like an image on a touchscreen. This story got me thinking that for many of us, our knowledge of what's going on behind that glossy display isn't much more than a toddler. There are many touchscreen technologies, but the most commonly used are resistive and capacitive. The resistive screens literally resist your touch, and if you press hard enough, you can feel the screen bend slightly. This is what makes the resistive screens work. There are 2 layers in resistive touchscreen, the conductive layer and the resistive layer. These are separated by tiny dots called spacers. The electric current runs through the yellow layer at all times. But when you touch the screen, the resistive layer comes in contact with the conductive layer. Thus, the electric current changes at that point of contact, and the function corresponding to that point is carried out. Resistive screens are durable and consistent, but they're harder to read because of multiple layers which reflect more ambient light. Ambient light is the surrounding light reflected back from the screen, making the text harder to read. Unlike resistive touchscreens, capacitive screens do not use the pressure of your finger to create change in the flow of electricity. Instead, they work with anything that holds an electric charge, including human skin. Capacitive touchscreens are constructed using materials like copper or indium tin oxide that store electric charges in an electrostatic grid of tiny wires, each smaller than a human hair. There's a glass substrate, a conductive layer, a protective coating, a controller, and electrodes at the corners. The electrodes apply a low voltage to the conductive layer, creating a uniform electrostatic field. When a finger hits the screen, a tiny electrical charge is transferred to the finger to complete the circuit, creating a voltage drop at that point on the screen. The location of this voltage drop is recorded by the controller. And this is how a capacitive touchscreen works.
Besides the energy recognition, how does the touchscreen know where we press? The answer is calibration. Most of the time, the touchscreen is mounted over an LCD or another display. If this is the case, the data measured by the touchscreen must be translated into true screen coordinates. Just like any other formulas used in chemistry and math, touchscreen calibration also requires a very complex formula. The result in the calibration are the x and y coordinates used in graphs. If the graphs are misaligned, such as the ones shown, then the calibration has to be fixed according to the original points. Once the coordinates are exactly the same, then the touchscreen is ready for proper use and it will be accurately calibrated.